Alright, a very good morning, good afternoon, good evening, and good night to all of you. We are back here again. I'm back here again with the next chapter. This time around is going to be chapter number 5, talking about hypothesis testing of the two variable model. In this chapter, you're going to discover explore new things for this econometric clause of EBE2174. But before that, also I want to show you also that it's the same thing here. That I've uploaded the Gujarati and Porter book. Actually, the 5th edition book in the ellipse. You can have a look of that under chapter number 5, which is what we're going to discuss for this particular chapter. So it's going to be two variable regression, interval estimation, and hypothesis testing. All right. So we're going to talk about this, and the first part will be on the interval estimation. We go back to the note, so you can always refer to the book of this, and have a look of that. All right. So what we're going to discuss today, especially in this particular chapter, will be that by the end of this chapter, you will get some idea of what is interval estimation, and to know how to conduct the one-tail or two-tail t-test of the significance, statistical significance, and to know what's the usage of p-value. This is like a repetition of what you have done, especially in your statistic, but it's just that now we go a little bit more deeper of what it can be used for, right? So surely, so the idea behind that, this interval estimation, the basic idea is that a single estimates of unknown population parameter is called point estimator. So this is what normally they do, a point estimator. But what we need to know is that how close is our estimator to the true parameter. So in this sense that we always use the sample to represent the population. So how close is the sample for the approximation of the population? All right, the precision of the point estimator is measured by the standard error. We also may construct the interval estimator. Interval means that from a point to the other point. Right, from point estimator such as the interval have this, for example, 95% probability to include the true parameter values. So that's what we're going to do. So for example, if we calculated 95% interval, means that the range of value that the 95% certain content the true mean of the population, and we know that with much more larger sample, that is more precise compared to the smaller sample. So comparatively, the confidence interval is quite narrow when computed from a large sample. Means that is reflected on the the true parameters, which is the population that we try to do here. This was discussed quite thoroughly in the previous chapters. Actually, refer back to our video. You can have a look of what does it mean to estimate the sample that going to represent the population. So what is confidence interval? So in terms of statistical inferences, statistical manner is one to which to estimate the population parameters using the observed sample data. Again, it's repeated here and there. So the confidence interval give an estimated range of value. So that's why it's called interval, right? Which you're likely to known unknown population parameters. Estimated range has been calculated from the given set of the sample data. That's what we're going to do also here. So for example, in this estimation, this is actually an output from the e-views, which we're going to explore that in the next few chapters, right? We're going to explore the program itself, right? So this is the estimation that we get. Y equals to alpha plus beta x1. It's actually 0.460, which is this part, the constant, and then the coefficient is 0.902 x, which is the x here, right? So this is the independent variable, the dependent variable. So how close, how reliable is the OLS estimation? how close is the beta estimated to the true population beta. So this is what we want to know from the sample regression function as a representative for the population regression function. Right, so what you're going to do here is to calculate the threshold or the interval between the true parameter, which is this is the measurement that related to the mean and the variance of the of this shape bell shape types of estimation data that we are using here. Right, so we're going to calculate the interval or the confidence interval, the random interval, where the betas will fall in these areas. The betas estimated will fall in this area. All right, so in this sense, we're going to calculate this one, and this one is also based on whether we choose what which significant level, whether it's 10%, 5%, or 1%, or in other words, it translated into whether whether we're going to use 90% confidence level or 95% confidence level or 99% confidence level in that sense, right? So this is actually the discussion for these slides already, even without removing the other side. So what's the confidence level that we're going to use? This one, or this one? That's a good question. Can we use three? All the three? Or can we use just one? So the simple answer for that is that you can choose your significance level, and you must be assured that justify that why you choose that significant level, right? So that's one of the more important criteria as a researcher, right? So how to construct? So the next few slides will be on the construction of the confidence interval for beta, right? So it's constructed based on the assumption of normality, right? Based on the assumption of normality as given in such assumption here, means that they are distributed under the assumption of normal distribution. That's why it's having the bell shape just now, as you can see, right? Which is this one. All right, so transform that into normal standard distribution. The actual beta, the actual estimated beta could fall into this region. So it depends on the confidence level or confidence interval that we are going to be calculated. Right, so this is the using the normal distribution to make probabilistic statement about the variance, provided the true betas is known as in such a way, right? So we estimated the variance in such a way so that we can know what's the true betas, right? The calculation of betas here. So this is the example of it. Let's say we use 0.95, which is more or less what we say about 95%, right? This is 95% acceptance region. Outside there will be is not acceptable in that sense. So we're going to calculate this value, means that we're going to calculate the threshold from a value up to the other value, right? This is what you're going to do here in this particular chapter specifically. All right, so moving into next direction, this is based on the calculation. So this is the formula that we're going to do, the plus minus day. This one is based on the significance level. Let's say here is 95%, right? So we're going to use it in terms of that. So t distribution is going to be used because it mimic the normal distribution in that particular sense. This is the construction, the calculation of it, the calculation of t statistics actually, and then we have to refer to the the book for the confidence level of it, and then we have to know what confidence level that we're choosing so that we can know the value of it, and then we're going to calculate it from there, right? This just to show, these few slides is just to show how it's being constructed step by step. So using the t critical value to construct the confidence interval for beta, as for example like this. So this is the formula, the probability, the t calculated, or the t from the critical value itself, right? And then where t is the critical t value at 2 tail level of significance, alpha is the level of significance, and n minus 2 is the degree of freedom in the case of this two variable case. Right, in this case, two variable. Let's say if you have more variable than the n minus d parameters in that sense, which will constructed based on the degree of freedom. Right. This is from the T table, the T critical table, not the one that we calculated. So this will be for the 90%. This will be for the 95%. Right. If you see here, it's because it's divided by 2. If you see the formula here, it's divided by 2. Right, so that's why it's something like this: 90%, 0.05, and for 95% it'll be 0.025, and they find the replace all this with the real figures, and you find out the answer for that. So for example, like this, right, the confidence interval for betas for 90%, for 90%. 90%, 95% will be like this. So 90% will be like this, 95% will be like this, plus minus in that sense. When I say plus minus, it's not necessary that you get a plus minus kind of answer for the interval. Let us see what is happening here. So for example here, again, we go back to the previous estimation just now. If we make the simple hypothesis testing, betas equal to 0, betas not equal to 0, you can see from here that this is the replace for this. This is the formula for T statistic. Is actually the coefficient of the betas minus 0 divided by the standard error. Right, you can see the formula is here actually. Yeah, the formula of T is here. Estimated minus the true parameters divided by standard error. Given that the true parameters coefficient is 0 in that sense. Right, given that. So with that calculation, we can get the result of this. This is where they get this result. Same thing goes, you can try this one. So actually, this is one of the things that they have done in advance in the pre-quiz that I asked you to do, actually, and the previous chapter, if you still remember that. Right, so basically that we have all the information. Let's say you want to calculate the confidence interval for this coefficient of beta. Right, so beta is 0.9020, right? 0.9020 is there. N is 41. You can have a look of this. Y is 41 here, the sample size. Standard error there is given also, right? 0.026226. So to calculate this confidence interval for 95%, then there will be something like this. This is from the T table. You can find from the T table, you can always compare this result. Times it, you solve for it, you get this result. Right, you'll get this kind of result. Right, 90%. Yeah. So solving for this 95%, you get this result. Yeah, this is for the 95% confidence interval. Means that this going back to the graph just now, the bell-shaped graph, the interval from here to here, right? So you have this kind of line, and then you calculate the range of which the coefficient could go as maximum and minimum. So that's the idea here. Right, that's the whole idea of having this and still belong to that particular region in that particular sense. So you can always try in the class when we do the online class, we will do this to calculate the 90% and to calculate the 99%. Right, we do that in the class, but not here in this video lecture. Right, so the next part, the first part just now was on confidence interval. We calculate the interval between a certain value, and all the information actually are drawn from the estimation itself, and also the T critical value. All right, so the next part will be on hypothesis test. What is hypothesis testing? Right, the hypothesis is something considered to be true for the purpose of investigation. Right, the hypothesis testing enables us to make inferences about the real world from the sample. The sample that you choose reflect the real world. Right, and we do hypothesis. So we have null hypothesis, null hypothesis, and alternative hypothesis. Right, to test the null hypothesis, normally we assume null is true. calculate the test statistic assuming the null hypothesis is to reject, right? And we're going to find the t critical value and then compare. The one that we calculated, we compare the critical value. So it's rejected, then you know that you're rejected the null hypothesis. Right? So going to show you a little bit. This is like the steps of doing the hypothesis testing. Again, this is one of the question for the pre-quiz actually, right? That asks you to do. So first thing first, when you do hypothesis testing, is that we need to state on the null hypothesis and the alternative hypothesis, and choose the test statistic. In this case, we choose T, and then choose the significance level. In this case, we have 5% significance level, right? And then after that, you're going to choose the critical region, or whether you use 5%, 10%, or 1%. So in this case, if you have two sites, or the t-test, then the critical value of t is about this value, 1.96. Easy, very straightforward thing. Then after that, we make the we do all the estimation, you get the result, and then we conclude. Right? For example, like this. This will be the one tell. Right? You state the hypothesis, and then you test the computed value, and then you compare with the t table. Alright, and then you make the conclusion. For example, here, decision whether to reject or do not reject, whether you're in left tail or right tail, depending on. Then you make this hypothesis. For the two-tail, it's very straightforward. This is the null hypothesis. Two-tail, very straightforward. Beta 1 estimated equal beta. This is estimated. The cap here means estimated, and then the alternative not equal. All right. So this is the formula which already been shown to you in the interval estimation, and then you check the critical value, you compare it, and you see whether rejected or not. And also, to go further, we can calculate the confidence interval that I've been saying in the beginning part of this chapter. For example, like this one tail test. Let's say we want to know whether that is beta 1 less than or equal 0.3, and beta 1 larger or larger than 0.3 if we reject the hash null. So it calculated in such a way to assume that the true beta is actually 0.3. So you have this value just now divided by minus this, and then divided by the standard error. So you get this value. You get this value 26.637 by theory. Supposedly, this is from the table. You compare it. We will reject the hash null. Reject the hash null means, in other words, means that they are larger than 0.3. Yes, they are, because they're 0.902 actually. Right? Suppose we can test also the two-tail. Can we use the confidence interval kind of approach to conclude? The confidence interval approach found out this result, 95 or 95%, has been calculated earlier on here just now. When we do this, before this hypothesis testing, we have this value 0.9476 and 0.8563, right, as a threshold or the value within that particular acceptance region, right? These two parts, either here up to here. So 0.9020 is actually between this figure, right? All right. So basically that's what happened. And same thing from the from what we are calculated, is that the estimated beta is not equal to 0.3, certainly, because it's much larger than that. So to prove that, actually, again, get this value, we compare it with the critical value, and then reject the hash null is not equal to 0.3. All right, you're moving to the end actually of this particular chapter before we move to additional part of this chapter itself. So what is meant by accepting or rejecting? Accept the null hypothesis. Oh, we're saying that on the basis of the sample evidence, we have no reason to reject. We're not saying that the null hypothesis is true and beyond doubts. So normally we don't use the word accepting null. We only use the word rejecting or do not reject the null. Right? Do not use the word accept in any means by any chance of that. All right. So this is another example of it on hypothesis testing, whether to use one tell, right? And this I mean the other example, you can always can always generate it from here, where this is the we have all the information needed. It's just that you need to calculate it, right? This one is for another example. Let's say you have this value. Stock market is not negatively related to interest rate. And if we reject, it's negatively related. So we have this. We have the sample size. We have the t calculated. The t from the critical value. If the calculated value is larger, then we're going to reject it. So we're going to apply this value, and then we get the answer. We compare with the calculated and the from the table. We found that they are rejected, means that they are not equal, means that they are in other words, in that sense, that they reject the hash null, right? Negatively related to interest rates, in that sense, stock market. All right, so that's what we are doing here. And for the null hypothesis, there's more example actually in the book. Can have a look of the the book that I'm saying just now. Let's have a look of the book. This book, when we talk about this Gujarati book, when we talk about interval estimation, this is some of the idea behind. You can have a look of this, of how they calculated it. You see, as what been saying just now, is based on normal distribution Z statistic. All right, so it's based on the Z statistic, and this is the formula that been saying just now, right? The formula to calculate the interval, right? The chosen significance level there is important, whether it's 10%, 5%, or 1% in this sense, and you calculated the value, right? How to interpret, like what we are doing there, also just now, like what I'm doing. Right, so confidence interval for the unknown here. So you have this confidence. This is the threshold or the confidence interval that we calculated. All right, let us looking a little bit more. So this is again more or less like what we're talking about in the chapter. This is on the hypothesis testing. All right, you have the two-tail. Right, this is the so-called the two-tail, and then you have the one-tail also in that sense. So from that perspective, we can calculate the confidence interval rather than just looking at that particular statistic or result for it. All right, and the one-tail in such a way. So solving for that equation, you get some results, and to give a conclusion. Again, like this one example, let's say the 95% confidence interval for betas under the hypothesis that beta 2 larger than or the hypothesis is 0.5, right? So the value of it is from 0.5, and this two value is actually the interval. The maximum it can go, the minimum it can go down, right? Well, that's the figure out. The whole chapter here again is about the hypothesis testing. It's about the confidence interval calculation. All right. Here again, just now, as I already mentioned to you, what's the meaning of accepting or rejecting the hash null? So most of the time, we just say that rejecting the hash null, all right, rather than accepting any of the hypotheses. All right. So the book here also show to you how to calculate or how to formulate null hypothesis, and the chosen level of significance means that this is the p-value, actually the discussion on the p-value, which we are going into. But let us see this book first, up to the end of the book. What's the meaning of that? This will be this section 5.9 will be when you do regression, right? Like we have done analysis of variance, which is called ANOVA. Okay, yeah. So let us move on back to the book, not this particular chapter yet, and move back to the notes here. So the p-value, in this sense, the p-value is the smallest significance level of which you could reject the null hypothesis. So again, you have to choose your significance level, whether it is 1, 5, or 10. All right, and this is an alternative information that you can use when you do not have the critical value to be compared. Okay, so giving this p-value, will be able to make a conclusion whether the variable is significant or not, and what should we do about that. Right, so statistical significance means that at 95% confidence level, we could reject the hash null, or at 5% significance level. Significance means statistical significance unless otherwise been explained in such way. So for example, like this, the claim that marginal propensity to consume is greater than 0.7, conduct one tell or one side test for the null hypothesis against the hypothesis here. So this one is an example of consumption or NPC kind of relationship, right? So you can always test this if you have enough data, right? With that, I guess we can ended up here. Then again, let's move on to the book itself. Have a look of this, how they've been used as the calculation, right? The other part of it, we're going to discuss of this a little bit on normality test. That's what we have here, normality test. And the last part of this particular chapter, normality test, we call it Jacques-Berat, the JB in short. Right, so this test actually depends on few important ingredients inside that form into the what we call as the Jacques-Berat normality test. So you have to know the skewness and the kurtosis, right? And this is the formula, and you use chi-square to for the distribution. What is skewness? What is kurtosis? Skewed means that either you skewed to the left, skewed to the right, and then skewness measured the asymmetry, the shape of the probability distribution. All right. If you have a skewed to the left or skewed this one, the best example of applying this is actually look into the exam performance every semester of every subject. This from the point of view of the lecturer. So if the result are more of the student actually getting C and below, means that it's going to be skewed to the other side. If more of the student are getting A minus, then it will be skewed to the other side, the other end. If more getting somewhere around B plus and so on, then you will see a very symmetrical shape of the distribution, or what we call here is the skewedness in short. Kurtosis is the measure of the thickness of the probability distribution of the random variable. Thickness, how thick, where's the highest peak in this sense? Here, are we here, and so on. So this actually also very much related to the variance, right? So this is the output example of output of EViews output from for the normality test. We're going to do this, but not this particular chapter. We're going to show you. I'm going to show you this. I'm going to backtrack this and show you this. From this output is the error term normal, because you want to see whether they are normal or not. If you see this blue thing, it's actually reflected something like this, right? If you draw up, do you think this is normal or skewed to the other side, right? And the important information here is these two, and you have to know that for normal distribution, skewness is 0, near to 0, and kurtosis is 3. 0, 3. They are not 0, they are not 3, skewness and kurtosis here in this result, but they are near to that particular figure, right? So in that sense, is the error term normal? Let's discuss this when we have our class in this particular chapter. If you have the answer, do let me know in the chat box or in the comment down here. Is the error term normal? You can answer this inside the comment box in this video, right? So then again, thank you very much for watching this video. Take care, stay safe, adios, and bye bye. See you in next chapter.